right, it's time for lesson 3.4, solving multi-step inequalities. So we've solved some basic ones with addition, subtraction, multiplication, and division. Now we're going to have some two steps, maybe some like terms, somewhere you need to use the distributive property. So we're kind of rolling everything that we learned into one. And I'm also going to show you a few special cases. There are always special cases in algebra, I'm sure you're finding. All right, so you can use the properties of inequality to solve multi-step inequalities the same way you use the properties of equality to solve multi-step equations. So we're going to solve these exactly the same way we do when we're solving equations. And don't forget what you learned in the last lesson. If you multiply or divide each side by a negative in order to solve the problem, you need to switch the sign. All right, so here's the first one. I'm going to draw my line. This is just like a regular two-step to me when I look at it. And the first thing I want to do is get rid of this 7 that's being added. So I'm going to add a negative 7 or subtract 7, whatever floats your boat. And I end up with negative y over 6. And then 9 plus negative 7 is 2. And now I want to get rid of the negative and the 6, so I'm going to put the negative with the 6, because we talked about before how it doesn't matter if it goes with the top or the bottom. So you might as well put it with the bottom so you can get rid of both of them. I'm multiplying each side by a negative. So that means I have y here, and 2 times negative 6 is negative 12. Because I just multiplied by a negative, that means I need to switch the sign up here. So it was a less than, I'm going to now make it a greater than. So your solution to this first one, y is greater than negative 12. Of course we're going to graph this, but you're used to this by now. Do a quick sketch. We're going to put negative 12 in the center, negative 13 to the left, negative 11 to the right. And if y is greater than negative 12, it means it can't be negative 12, so open circle. It can only be the values greater than, so I'm going to shade to the right. All right, letter B. Draw down your line. Again, this is like a two-step. So I want the variable term 9c alone first. That means I need this 8 to go away. So to cancel out a positive 8, you can add a negative 8 or subtract 8. Same thing. I'm left with 0 plus 9c, which is just plain old 9c. And when you take a negative 28 plus a negative 8, you get a negative 36. Now, I need to get rid of this 9. It's being multiplied by the c, so I'm going to divide each side by 9. 9 divided by 9 is 1, and 1c is c. Negative 36 divided by 9 is negative 4. Now, I know that there's a negative sign here, but I'm not dividing by a negative. I'm taking a negative divided by a positive. I don't need to flip the sign in this one because the coefficient here wasn't negative. So I'm going to keep this as greater than or equal to. So c is greater than or equal to negative 4. Graph it. Negative 4 in the center, negative 5 to the left, negative 3 to the right. And if c is greater than or equal to negative 4, that means it can be negative 4, so I will close that circle. I'm going to shade to the right. It all of a sudden just reminded me of the cha-cha slide. Maybe I'll sing that one for you tomorrow. Maybe you'll sing it for me so you don't have to listen to me sing. Anyway, letter C. We have some parentheses going on. Remember, let's do keep change change so that we know that that's really a negative 2b. Otherwise, it gets lost in the shuffle sometimes. So the first thing you should do is get rid of those parentheses. And since we can't take 8 plus negative 2b, they're not like terms, to remove the parentheses in this case, we need to use our distributive property. So I'm going to distribute the 4 to both numbers inside. 4 times 8 is 32. Bring down that addition sign. 4 times negative 2b is negative 8b. And I still have plus negative 2b left. It's not next to anything, so I just drop it down. And over here we have 32. Now, on this side of the equation, I see that we have some like terms. I have a negative 8b and a negative 2b. So now what I'm dealing with here is 32 plus negative 10b equals 32. Okay, now we're at a two-step. So get rid of this 32. You can do that by adding a negative 32 or subtracting 32. Oops. And negative 10b is left over here. And on this side, yeah, 32 minus 32 is 0. It's okay to get 0. 0 is a number too. There's a book actually called 0 is My Hero. So there. All right, let's get rid of that negative 10 by dividing by it. So 0 divided by negative 10, that's not the undefined one. 0 is allowed to be in the numerator spot. It's just not allowed to be divided by. So 0 divided by negative 10 is 0. And you see how we just divided by a negative 10? That means that this is no longer less than or equal to. we have to switch that sign to be greater than or equal to. So for the graph of this one, I have a 0 here, -1, 1. If b is greater than or equal to 0, it means it can be 0, so I'm going to fill that circle and shade to the right. All right, so kind of just like solving equations. I told you they'll never go away. Equations will never go away. And aren't you glad? Because they're so fun to solve. All right, it's story time. Woohoo! I know, it's the best time of the day. All right, put on your listening ears for math story time. Okay, I'll stop it. You need a mean score, and they're not talking about one that's really mad. It's an average. You need an average score or a mean score of at least 90 to advance to the next round of the trivia game. What score do you need on the 5th game to advance? So what makes this an inequality and not a regular old equation is it says that you need a score of at least. So that means it can be 90 or it can also be more than 90, right? So your mean score needs to be greater than or equal to 90. Now to find an average, don't you add them all up and divide by how many you added? You're only given 4 here. I want to know what the 5th one is. So maybe game 5 we can call G for game 5. Why not? Okay, so to find an average, we're supposed to add them all up and divide by the number we added. So what I would do is I would take 95 plus 91 plus 77 plus 89. Add up those 4 that you do know. And when you add up all of those numbers, you get 352. So 352 plus what divided by 5 will give me a score that's at least 90. So my equation will look a little something like this. 352 plus that other game, that 5th game, divided by 1, 2, 3, 4, and we're putting a 5th game in there, 5. If it needs to be at least 90, that means that this amount can be equal to or greater than 90. So generating the equation, I think, is the biggest battle. From this point, I think we'll be okay. Your first step in this, you need to get rid of that denominator. So in order to get rid of that dividing by 5, we're going to multiply each side by a positive 5. And we're left with 352 plus G is greater than or equal to. When you take 90 times 5, you should get 450. And now I need this 352 to go away. So I'm going to subtract 352 or add a negative. And that means that G is greater than or equal to, when you take 450 minus 352, you end up getting 98. So in order to advance to the next round, that means you need to get a 98 or more on your next score. All right, story time is over for today. I know, it's so sad. Now we're going to talk about something very special. Special cases. Because sometimes when you're solving an inequality, there are no solutions. And sometimes any number you plug in can be a solution. So you'll kind of know when you get there. You'll get to the point where you're like, well, what am I supposed to do now? The x's are gone. So take a look. Some inequalities are true no matter what value is substituted for the variable. For these inequalities, all real numbers are solutions. If the same variable term ends up on both sides of the inequality and the statement is true after you cancel them out, the solution's all real numbers. So I'll show you what that means. Let's say I give you an equation like this, and I ask you to solve it. Well, you want all the letters on one side and all the numbers on one side. So let's start off and get all the letters on one side. So I'm going to subtract this x from both sides. When you do that, x minus x is 0 and you're left with 5, and x minus x is 0 and you're left with 3. Now we subtracted x. We didn't multiply or divide by a negative, so I would keep my sign the same. And when you bring down the symbol, this says that 5 is greater than or equal to 3. Is 5 greater than or equal to 3? Because it can be either one of those. So because this is true, this means that my answer is all real numbers. So you can kind of know this is going to happen when you see that you have the same variable term on either side, because they're going to end up canceling out. If after those variables cancel out, the inequality statement is true, that means that any number you plug in for x is going to make this true no matter what. This word is true. Sorry. Sorry for my scribbles. Okay, now opposite that, some inequalities are false. No matter what you do, there is not a number that I could plug in there to make it true. So to tell if it's false, after you cancel out your variables, the statement that's left will be false. So let's try it. I have 8x minus 3. I'm going to use the distributive property here. I get 8x, and 4 times 3 is 12. Now, I have an 8x here and an 8x here. If you subtract 8x from each side, you end up with a negative 3 being greater than 12. Is negative 3 greater than 12? No. So this right here is not true. That means that there is no solution. So it's not just about there being the same variable on either side. It's about what happens after the variables cancel out. So again, if the statement at the end, after they all cancel out, is a true statement, then all real numbers are your solution. Oh, actually a fancy way to say all real numbers is to draw 2 lines and make an R like that. That means all real numbers. You don't even have to write all those words out. You can just make that simple. I got nothing for no solution. Sorry. All right, so negative 3 is not greater than 12. No solution for that one. We're done. See you tomorrow.